Hey, what is going on, guys? Welcome back to the channel. Today is one of the most exciting days I've had in the shop in a very long time. You guys saw the title, I bought this thing a month, probably about 3 weeks ago now, almost a month, and I've been doing my research. I've been watching a ton of videos trying to figure out how to use this thing. So I've been needing one of these for so long. I cut a ton of steel and I'm getting sick of the old cutoff wheel, the grinding flap disc. I'm getting sick of all that stuff. I kind of want to just hit a few buttons and have a nice piece of cut steel. So I decided I'm gonna buy a plasma table. So I picked up a table from Langmuir Systems. This is the Crossfire Pro. This is a 4x3, or really close to a 4x3 table. Now they do have a smaller one. I think once you buy their little expansion kit, it's 25 by 33. Now I was gonna buy that just to kind of save some room in the shop, but I decided if I'm gonna buy a table, I might as well just buy a decent size one. That way, in a couple months when I decide I wanted a bigger one, I don't have to buy another table. So we did the Crossfire Pro. I am so excited for this thing. I honestly haven't even got the whole table yet. I'm waiting for one more big box, but we do have the box with all the frame and then all the hardware, and should be all the electrical too. So we should be able to get the whole frame together, get the electrical box mounted up and all that good stuff. And we got to make some room in the shop for it. I've already kind of rearranged the shop a little bit just to make some room over here by the compressor. I'm gonna move that little bench out of the way, and the plasma table is going right there. Also, another thing I did have to buy is a new plasma cutter, because the one I think I have a Lotus. That thing is a high frequency start, and that screws with the electronics on the plasma table. So I bought a prime weld cut 60. The nice thing about this one, it's got a CNC port on the actual plasma cutter, so we can wire directly from that to our plasma table, and we don't have to mess with, usually you have to take the plasma cutter apart, get inside of it, and get your like voltages for the torch height controller, all that kind of stuff you got to get inside of the plasma cutter. This one, it's got a port on it, so we can wire directly to that port. Now, like I said, I have been doing all my research, but I still got a ton to learn about this. There's a lot on the back end, kind of on the computer side of things, that I really don't know about. I've never really done any CAD design or anything like that, plus never messed with G-code, any of that stuff. So I have a ton to learn about, but I think I got a fairly good grasp on what kind of the basics are. So that being said, guys, let's get to work with the table. So that should be all the frame, and then that box should be all the electrical and all the hardware. So let's bust these things open, see what we got, see if we can get this frame together. Well, we made it a lot farther than I thought I would with our boxes that we got. So I'm still waiting for that one box, which has the whole water table. I do have all the slats and everything up there, but the table itself, and then there's a bunch of like corner gussets that go on this table, and maybe a few other little things. Oh, the torch height controller, which controls the height here with another, or with this motor, I guess, here. So we're waiting for a few more things, but we got this thing ready to go. We got our limit switches installed, which is that one and that one there. What's super nice about those limit switches is you can just come, you don't have to set your zero every time. So you got the machine settings there, and then you can get this thing out of the way over here, and all you got to do is hit home and home machine, and it goes right back to home, right where it should. And another thing I did was set the soft limit, so that is on this side. So you basically run this out to right before it's going to smack into that bracket there, and on the x-axis too. So this machine will never bump into these brackets, or it'll never smash into that bolt over there, because with these soft limits, so it stops it before it hits all that. So that's super nice having that limit switch. And also with that, you can see all the coordinates are right here. This is basically your cutting envelope right here, this square. Without the limit switches, I don't think you have that. So like I said, once we get the other box in, which is supposed to be here tomorrow, we can get the whole water table in, get this thing filled up with water. We do have to bust out the new cutter, but that is going to be tomorrow as well. So once I get that box in, we'll get this thing finished up, get all the gussets on, get the table in, get the torch height controller all set up. There's one, you can see THC, the plug right there. We got to wire that in to the torch height control, like I said. All right guys, we are just about ready to start cutting. One thing I'm gonna do real quick is I downloaded the break-in program, and you can see the cut line or the break-in line basically just goes back and forth across the two axes just to kind of break in everything, make sure everything's moving smoothly, make sure there's nothing binding up. Now we did go through and I did weld this water table together. They do give you sealant for this flange right here, but I figured it's kind of a common area to leak anyway, so I just TIG welded that up. That's never going to leak now. One thing a lot of people do is swap these drains out. I did buy some better drains just because you can see it's only like a little 1/2-inch hole, so I bought some bigger drains for those. I haven't got them yet, so once we get those in, we'll throw new drains in it. But for now, let's run the braking program, get this thing broke in, I guess, and make sure everything works smoothly. And then we got to hook up the plasma. We already got the torch mounted and everything. All these wires are good to go, but we do need to hook everything up to the plasma. And then I did buy one of these motor guard filters just because you really want some clean dry air. I do have a desiccant filter here and a water trap, but I figured just for the plasma table I'm going to run that dryer too. All right, we got Fusion 360 loaded up here, and we are going to go design something real quick. Just something very random. Not even sure. It's just going to be kind of whatever. Make some angles here and there. Oop. Something like that. I want to try some inside holes too. So we'll do 0.4, that'll work there. Let's try one a little smaller, 0.25, try a 1/4-inch hole. That looks good there. Let's go solid. We're going to extrude it real quick. 0.125. I'm not sure if this is necessary, but you can see we got a part. I'm going to put one more line wherever that line tool went. We've got to do that, get our line. I'm going to put a cut line just down the center so we can measure our kerf width there. Now we should be able to go to manufacture, and we want to create a new setup here. So you want to select cutting through there. Alright, we got fire control open. Let's open that test file we just made. And you can see here, we got our part here, but you can see it's over. So this square is our machine, basically the plasma table. And you can see that line is over the actual machine. So we need to move that in a little bit. I'm not sure. I think we just nest. Oh, there we go. You just manual nest and move that over. All right, so let's do a dry run without actually firing the torch. So dry run, and we'll hit start and see what this thing does. Looks like it's cutting it out, the circles first. That looks like the outside perimeter of it. And you can actually watch it on the screen as well. So program complete. Looks like it worked. Let's get some steel, get it on the table, get it grounded, and see what it does. All right, so what we got to do is set our 0. So I'm going to put the bottom left corner kind of right in this corner here. So we'll just toggle this with the buttons there. Get that where we want it. So yeah, right in that corner. So we can do, come in here, 0 all work axes. That makes that start point right down in that corner, right where we're at. Before we cut this out, I'm gonna do one more dry run with the steel on there. So I'm gonna raise up the torch a little bit, dry run, and we'll start that. And that looks like we're good. Let's get this thing fired up and cut it. Well, I haven't even cut anything yet, and I am so glad I went with the Z-axis control or the height control. Just putting this one piece on, it was warped a little bit. I clamped that, but you can still see it's kind of bent or warped a little bit. I'm not sure what from, but it is not straight. So with having this height control, as the plasma is cutting, it senses the voltages and it varies, and it keeps that same cutting distance from the actual steel. So when it warms up, when it starts to warp a little bit, or if it's sitting on here not flat like it is right now, it's going to keep that same cutting height all throughout the whole entire cut. Check it out, first cut was a success. Let's get this torch, let's get that on continuous, and let's get that out of the way. And let's check this out. So I know that line, like I said, in the center, the pierce was on the side of it, which I knew, but all in all, not too bad. Looks like a pretty decent cut. The back does have some dross or some slag. That's just settings, I guess. Now the spring back, there's a spring back setting. I think I set that at 1/1000 or maybe 10,000ths, and you can see that's a lot more than 10 thousandths. So I'm not sure. It was probably just cutting too high. That's why there's so much dross on the back, but I'm gonna mess around with it a little bit more, see if we can get this thing to cut. I'm gonna clamp this down, or get a, maybe a cut one out over here where it's more solid. See if we can get the right cut height and everything, and see if we can get a little bit cleaner of a cut. All right, as you guys can see, I'm having some issues getting this thing to cut right. So you can see like that one, it didn't even cut the hole. It didn't cut that hole. And it's just very, very sloppy. It's tapered. The torch height is too high. And what I was doing was I was cutting, and then I'd pause the cut and get feeler gauges out and measure the distance between the torch and the metal. I have it set at 60 thousandths, which that's right where it should be, but I was cutting at like 100 thousandths. So it was way too high. And I went down in the post processor where you actually set that height, and I've taken out spring back. I have dropped that down to 10 thousandths, and it's still cutting at like 70 thousandths. So something's going on. There's a few things you can do in fire control with the torch height control. So right here you can see it, you can either do this, it's cutting on smart right now. You can switch it to nominal, which you actually set your own voltages in that field. So the voltage is actually, it senses the voltage and it keeps it at a certain volt while it's cutting. But in order to do that, we need to get the right volts. So what we're gonna do is unplug this height control so that this motor doesn't move at all, and we're gonna drop it down to where it's 60 thousandths, and we're gonna do like a 9 or a 10-inch cut and see if that cut is good. Then while it's cutting, we're going to be watching the voltage in here. It shows the live voltage. We're going to take that voltage, plug it into the nominal voltage, so it holds that voltage throughout the entire cut. And I think that's going to help. So let's do that real quick and try that. If that doesn't work, we got other issues, something to do with maybe the torch height control. I'm not sure, but let's see if we can figure this out. All right, guys, we got our torch right at 60 thousandths clearance between the torch and the metal. I got this unplugged, so that is not going to move up or down. That motor is staying right where it should be. Now, fire control has this straight line, straight cut right here. So I got that set up for the Y axis right here, 9 inches, 80 inches per minute, pierce delay 0.7 seconds. So we got that generated. Now we're just gonna cut it, and we're gonna watch this live voltage, and if that cut turns out good, we're gonna take that live voltage, go into here, into the nominal, and just throw that right into nominal. So we were right about 80 volts, so we're just going to go into settings. In this nominal voltage, we're going to put 80 right there and save that. So now we're going to be, this machine's going to be trying to keep that torch at the right height so that it's sensing 80 volts through it. So let's see if that works. One other thing I'm having an issue with, it kind of did it just a little bit, not even on the full cuts, just in sections of the cuts. It did it once over here where it's like super jagged. I don't know if you can see, yeah, you can see right there where it's not straight. So I think something might be binding up a little bit. So I'm gonna go through the whole table and make sure everything is moving smooth and free. Something with these bearings maybe is jagging, or maybe it's something to do with these rails. I'm not sure. I'm gonna go through everything and see if I can figure out what is going on. I finally found the problem, guys. I did another cut here, and you can see how jagged it is. I did another cut right here, and you can see it did kind of the same thing. It didn't even cut through most of it, and I just did the cut above it, and that thing is freaking perfectly clean. I haven't looked at the bottom side of it. What I did is I swapped out the tip. So I bought a few different sizes. I had a 0.9 tip. I put a 1.0, but I had a 0.9, and there it is right there. You can see pretty nasty, and I've done just those cuts you guys saw. Pretty nasty right there. The electrode was burnt. If it'll focus, you can see the electrode's kind of burnt right there too. I think I just overheated this tip. This is good for 30 to 40 amps. I'm running at 40 amps. So I think I just ruined the tip. So with a 1.0 tip in there, this thing cuts like new. So I'm gonna grab this file again. I'm gonna run another one of these and see what it does with a bigger size tip that's not blown out. All right, we got this part back in here. Let's go through and let her rip, see what it does. You can see when the part drops in, sure kind of splashes off the side of the table, but I think we got a lot closer now. Look at that. We actually got a straight cut. Dross on the back side, actually, that's really clean. There's a little bit around these holes. Oh, that just popped right off. Can't complain with that. That one, oh, it popped right off too. That pierce right there is a little dirty, but all in all, that is actually really clean, and it's square. Before on these ones, you can see it's pretty angled of a cut because it's too high, and I guess that that nozzle or that tip was all messed up. So with that being said, I think that fixed our issue. All right, I did some more testing with different speeds and everything. I went from like 120 all the way down to 70. I don't notice a huge difference. You can see they all got a decent amount of dross. I don't know what else could be causing that besides speed. This one here, you can see I scraped it off and it came off really easy. So it's not a huge deal having this stuff. I mean, I'd like to be able to cut it a little bit cleaner, but it's easy to come off. So not a huge deal, but all in all, I'm digging it. I like it. We'll get her dialed in one of these days. Well, you can see we still got a little bit of taper, so that line in the center right there, is definitely wider on the top side. On the back side, definitely a little bit narrower. So we're still cutting a little bit of a taper into it. Well guys, I'm gonna wrap this up here. We are cutting. I am happy. I still got a lot to figure out with that little bit of a taper we still have and the little bit of dross we still have. I think I can get it better. So I'm gonna do some messing around. The next video, we gotta build a bunch of stuff out with this machine for this machine. So I'm excited. I just wanted to get this thing done. I wanted to get it together and cutting in this video, and we did it. We are cutting. I couldn't be more excited to get this thing done and cutting. So like I said, next video, I want to build a whole bottom shelf for it. I want to build a mount for the plasma cutter. I want to build a little shield for the torch because the water kind of splashes up and it can actually short that switch out. So I want to build a couple splash guards. We got some fun stuff to do, so don't miss the next video where we actually cut some stuff out we're going to use, put this thing to the test, and hopefully not mess anything up. Well, that's it for this one, guys. I really hope you enjoyed it. I hope you're excited as I am. I have so many ideas on what I want to build. I can't wait to get to work with this thing, get this thing dialed in, and start cutting real parts. Well, that's a wrap, guys. I really hope you enjoyed it. Why don't you go smash that thumbs up button, comment, subscribe. We'll see you in the next one.